Alright, so given a particle moving along a straight line with velocity v on the time interval from a to b, displacement is the integral from a to b of velocity, and distance is going to be the integral from a to b, the absolute value of velocity. So this makes sense because we know that basically distance, it's saying that distance is the total amount traveled, so there shouldn't be anything negative there compared to displacement, which is just finding the distance from the start point to the stop point. So finding the so here it says find the displacement on the time interval from 1 to 7. So displacement, our formula is the integral from a to b of v of t. So here, integral from 1 to 7 of v of t. So v of t is just going to be this t squared minus 7t plus 10 dt. So the antiderivative of this, we add 1 to our exponent and it becomes t cubed. And we divide by our new exponent, so 1 over 3. Or you could have said t cubed over 3 minus t, there's an invisible 1 there. Add 1 to your exponent becomes t squared. Divide by your new exponent, so 7 halves. Again, you could have said, for this one, you could have just said 7t squared over 2. Plus, here it's just a constant, so we're just adding t to it. So this becomes 10t. The integral goes away, becomes this bar that just means evaluated from 1 to 7. So now it's just like what we did last quarter where we're just plugging in. So it would be the top minus the bottom for this. So I'm going to say 1/3, and this will become 7 cubed minus 7 halves of 7 squared plus 10 times 7. And this will be minus 1/3 of 1 cubed minus 7 halves times 1 squared plus 10 times 1. Sorry, that got messy. So this, you can simplify it if you want. We're just going to leave it like this here. I trust you guys can do the algebra. Now, for the distance the particle travels, it gets a little bit complicated because first thing we have to do is we're saying the integral from 1 to 7 of the absolute value of v of t. So remember from last unit that we needed to split this into multiple integrals. So first thing I need to do is I need to find out where this integral changes sign, or where v of t changes signs. So I'm going to say v of t, make a sign chart, or I'm going to factor it first, sorry. So t minus 2 times t minus 5 equals 0. So t equals 2 or 5. So now I'm going to make my sign chart, and I'm going to have here, I'm saying from 1 to 7, and I know I'm changing signs at 2 and at 5. Then from here, I'm going to do my factors. So between 1 and 2, so like a number like 1.5. So 1.5 minus 2 is going to be negative. 1.5 minus 5 is also going to be negative. Negative times negative is going to give me a positive. So I plug in positive. Now, because none of these factors are raised to an even exponent, I can actually just go like plus, or I should do more of this color, plus, minus, plus, or you can continue to do out your factors if you want. So I will show you the factors. My next two factors are going to be here. So I know a number between 2 and 5, so I'm going to go with 3. 3 minus 2 is going to be positive. 3 minus 5 is going to be negative. Here, positive times negative is going to be negative. For my last one, I'm going to say here, 2 factors, 1, 2. And I'm going to do, for this one, it'll be, so a number like 6, 6 minus 2, positive, 6 minus 5, positive. Positive times positive also gives you a positive. Now, if I want to keep going with this, so I know that I need to split this into 3 separate integrals, the integral from 1 to 2, 2 to 5, and 5 to 7. So I'm saying integral from 1 to 2 here of v of t plus, or sorry, here, v of t dt plus integral from 2 to 5 of v of t dt plus integral from 5 to 7 of v of t dt. And because it's displacement, what I need to do with each of these integrals is I need to just take my answers and I'm going to make them positive. So I'm just taking the absolute value of each integral, like that. So from here, it's the same process that you did here. I'm going to let you guys try that on your own. I will post the answer in the slide.